30 seconds gone. Thirty seconds remaining. I mean, you can just make a rough calculation. If not so precise, it's okay. 10 seconds. 5 seconds. Okay, let me tell you.
1 second, I'm almost done. I almost got done. It is 28,260
Unit?
centimeter. No, millimeter cube.
Kg per millimeter cube. Okay, quite strange unit. But of course, in these cases, actually, first thing you have to do is check the options. Like you have to first of all check the answer only in this case, in which unit they are trying to ask. Because tomorrow when we sit for an exam, first thing is we check the SI units in which the options are mentioned. Okay.
1 second, I found the volume. I have to find the density.
Okay, fine. Wait. Now check how do I solve, huh? See, I'm solving.
Yeah.
And where is the question? Okay, huh? So cylinder of diameter 6 millimeter and 25 centimeter long. Okay. So what I will do is I will convert it into meter. Usually I personally do that so that the things are in SI unit. Easier for me. So density equal to mass by volume. So where is mass? It's 10, right? Pi. What is the volume? It's pi r square.
Pi r square. Yes.
R is 3 millimeter, right? Its the diameter is given 6. So the radius will be 3 millimeter. So it will be 3 into 10 to the power minus 3. If you square it, it will be 9 into 10 to the power minus 6. Watch. Now don't look at copy. So pi r square. How I have done r square is clear?
Yeah, clear.
Okay. So pi r square multiplied by h, that is 25 centimeter. So I'll write 25 into 10 to the power minus 2 meter. That is the answer. So this 10 to the power minus 6 and 10 to the power minus 2 becomes 10 to the power minus 8. You know this?
Yeah.
They will go above and become 10 to the power 8. I have removed these two, send them up. It becomes 10 to the power 8. And 25 9s is 225. 25 10s is 250. And 25 9s will be therefore 225 multiplied by pi. So we can just leave it pi for the time being. So the answer is 10 to the power 9 by 225 pi. kg.
So can you explain again how that 10 to the power minus 6 and 10 to the power minus 2?
Okay, wait, what I will do now, I will share my screen. It's still visible, right?
Yeah, it's still visible.
Yeah, now it's still visible, right?
Yeah.
There was this is okay. See, I needed to find out the density, right? Mass was, I guess, 10 kg.
Yeah.
Volume pi r square h. So pi R square was clear, 9 into 10 to the power minus 6.
Yes.
And H was 25 centimeters, so it's 25 into 10 to the power minus 2 meters, right?
Yeah, clear.
Okay. Now you see, if there is something like 10 to the power A multiplied by 10 to the power B, so it becomes 10 to the power
AB.
A plus
A
B.
plus B. Okay.
If it's in multiplication, exponents get added. Why? See, say 10 to the power 2 into 10 to the power 3, okay? So how many 10 is here? 2. And how many 10s are here?
3.
Yeah. I'll expand.
10 into 10 into 10.
So how many 10s you are getting?
5.
Yeah.
Total 5.
Therefore, they get added. Got it?
Yes.
So 10 to the power minus 6 plus 10 to the power minus 2. I mean 10 to the power minus 6 plus minus 2.
So 10 to the power minus 8.
10 to the power minus 8. Okay. So now what we are getting is 10 by pi, and 25 nines are 225. Okay. This is clear. I mean, you can do it also. 25 nines you can do like that.
Okay.
Okay.
Yeah.
Yeah.
Yes.
And further, it's 10 to the power minus 8 here. Okay. So 10 to the power minus 8 is 1 by 10 to the power 8.
Yes, 1 by 10 to the power 8. So it goes up. So it will become 10 to the power 8.
Yeah. So this is how much? 10 to the power 9 pi.
Yeah.
Pi
220. Pi 225. Yes.
And simplify it kg per meter cube. Now we don't simplify this further unless we have some options with us. Like if 4 options are given, we can solve and try to check.
Okay.
But solving this is like futile unless it's an objective question.
Okay.
That's the options. Got it?
Yeah.
Now solve the next part of this question. That is also good.
1 second, I'll just take the screenshot of how you have solved it.
Okay. You don't take this? Okay, fine. Take a screenshot.
Later, I got it.
Done?
Yeah, take it.
My screen visible now? Questions?
Yes.
So now do you try to solve the second part of this question? Okay. That if the cylinder is again melted and recast into 7 equal sized cubes, find the density of each cube.
Density remains same. Because density won't change, right? Though the mass, because mass and volume also keep changing, because they also reduce, so the density will remain same.
Ah. Actually, when you melt something, then its density may change.
Oh, okay.
Like if you cut something to pieces, like say for example, you have your copy, or not copy. Yeah, you have suppose one page of your copy. You tear that into 100 pieces. The density of one piece will be equal to that of the entire page itself.
Yeah.
Because essentially it's still the same thing.
Yes.
But if you burn the page, and then when it becomes ash, then it's a different substance now. It's not the same substance. The density of that will certainly be different. In a similar way, but still what remains the same, it is the mass. Even if you burn entire copy, don't do, I mean, you're getting what I'm saying.
Yeah.
Take a page and if you burn it, then if you get what the ash which you get, it will still have the same mass, provided nothing is lost to the surroundings. Some mass. Mass always remains constant.
Okay.
10 kg, essentially that will always remain the same. But the volume may change, the density may change certainly. Because now it's a different thing altogether.
Oh, but okay. Yeah. So what will be the density then?
See, the question is a bit, you have to understand. First, what was there? 10 kg metal was there, right?
Yeah.
Now it is melted.
Yes.
And then it is recast into a cylinder,
Yeah.
and the volume of the cylinder is given to you.
Yes.
So if the volume is given, then we found the density, right?
Yeah.
Now that particular cylinder is melted again, and now it is recast into 7 equal sized cubes. We have to find the density of each cube, right?
Yeah.
So in this case, what you're supposed to do, it's a cube, and now we know, now in this case, and the volume is not going to change.
Why?
Initially there is a, like, initially there is a cylinder, all right? You melt
Yeah.
this cylinder, make it into liquid. Again, when you recast it, I mean to say, again you have to like cool it down. And like you have taken, say for example, like say you have a utensil filled with that molten liquid,
Okay.
which you have got by, melting that particular cylinder, all right?
Hmm.
Uh, Now, this particular volume of this thing which you have in the vessel right now, you have to again, I mean, condense it and make it into uh, conical, that, what is that? Cubes, small, small cubes. Okay.
Yeah.
So now the volume will not be lost. I mean, the volume of the cylinder which was originally there and the volume of these cubes, the total volume will remain the same only.
Yes. And mass also remains the same only. So
Mass
the
also,
density remains.
so the density in this case will remain the same.
Yeah.
Yeah. See, when it
Okay.
is,
Got it.
when the question it is asked to, find the density of the cylinder. The first part when it was asked, na, find the
Yeah.
density of the cylinder. Then ideally speaking, that density should be same as that of the metal.
Yes. Yes.
I mean, like how to explain it to you? Let's show you by a diagram, otherwise it won't be clear. See, here is the cylinder. I mean, initially there was some solid. I don't know. We don't know what this is. Okay. Say
Mass was 10.
mass is say m. Okay.
Okay.
Say this cylinder is at a temperature. I mean, the solid is at a temperature of T naught.
Okay.
Now this is melted, and in a vessel I keep the contents of it. This is the molten form. So the density of this will be something else. Like I'm mentioning it. Let's say mass m, density rho, volume v. All right. And let us take m naught, rho naught, v naught. Naught means initial. Like this is T. It's pronounced as naught.
Okay.
NOT. Okay.
Okay.
Now you see, when we melt this and we put it inside this container, now the mass is still going to be the same. Mass won't be changed ever.
Same.
Until
Okay.
as you throw something out from the solid, mass will not change. But now because you have melted, it's a different substance altogether.
Hmm.
You got it?
Yeah.
So density will be changed. So density 1 and therefore volume 1 is changed.
Okay.
And this is at a temperature of T1.
Yeah.
Now it's not at the same temperature. Now again, when you recast it, recast means you take this and you cool this liquid down. You give it in a shape, like when how a metal is recasted, this
Yeah.
molten form which is there, no?
Hmm.
So if you have to make a cylinder, then you take a hollow substance like this, which is in the shape of cylinder of the desired radius and desired height. It's hollow, okay?
Hmm.
It can be something of concrete, and you pour this molten liquid into this.
Hmm.
So this entire thing gets filled with the liquid, all right?
Hmm.
And now you cool the liquid.
Okay.
So recast basically means like cool it, cooling. So when it cools, it gets hard.
Ha.
Got it?
Yeah. Yeah.
Like when they make the murtis of the Lord, there's some Krishna murti, and it is made up of an alloy. So how do you think it is made? First, they take that molten liquid of that alloy,
Hmm.
and then they have some shape, external hollow shape. They take that
Yeah.
molten liquid, put it in that shape, and cool it down. Then that murti, it gains a particular form upon cooling, and then they take that hollow portion out. They take the murti out. That's how
Yeah.
it is called recasting. So now, if say for example, if it is recast, and now the temperature again becomes T naught,
Same temperature.
same temperature,
Okay.
so it will be same substance.
So then all the mass, density, volume will be the same.
Yeah.
Not.
Yeah. So although different shapes are different, this shape and this shape is different, but the mass, volume, density, everything is the same.
Okay.
Why? Because they're at the same temperature. See, if you change the temperature, then the density will change actually. Because upon heating a solid, I had told you, the molecules, they have a tendency to go away from each other. They expand.
Yes.
All right. So on heating, generally, the density reduces because mass remains same, but volume increases.
Volume increases.
The density will decrease.
reduce.
So now this thing is formed. Now what they said that they have melted it again and made it into again melted, and again they have recasted into 7 cubes.
Small cubes.
So the total volume of all these 7 cubes will be equal to that of the cylinder.
Okay.
Got it? If they
Yeah.
are if they are again kept at a temperature of T naught, so T naught should be there. Got it?
Okay.
Now you see this volume we have found out. Cylinder's volume we just found out, right?
Yeah, we found out the cylinder.
So now 7 cubes
Even
are
the
there.
density.
So 7 cubes are there. Now can you find volume of 1 cube?
Volume of 1 cube. Okay. It's just by 7.
It's just by 7. So that will be the answer.
Yeah.
Okay. So I
Yeah.
just gave you hints. Now what you do after the class, you solve the question in detail and check the answers.
Okay. Okay.
Got it?
I'm sorry. Yeah.
What do you infer about their densities? Whose densities?
Both the cylinders and the cubes.
So they should be same. And the liquid density should be different.
Liquid, yes, the melted one.
Yeah.
Malt.
So after the class, you once confirm this.
Yeah.
Okay, now
Yes. Next doubt is that in the brain nurtures second one.
2 silver cubes have their volume, the ratio 4:5, and the ratio of their densities and their masses. And the ratio of their densities. Equals to okay. Volume are in the ratio 4:5 and the ratio of their densities. So let us say there are 2 silver cubes, silver cube A and this will be silver cube B. So what is the ratio of what was given? Ratio of the volume,
Volume.
and we are supposed to find the ratio of their densities.
And mass.
Okay. So see, because both are silver cubes, so the material essentially is of silver, right?
Yeah.
So properly speaking, because both are silver, so the density should be same
Density will be same.
because it's silver only ultimately.
Hmm.
Either you take a golden helmet or you take a golden tube or you take a golden cylinder. The density of because it's all made up of gold, so density should be same.
But the volume is different, then how can the density be same?
Because density is a property of the body. Like say this, you are seeing this highlighter.
Yeah.
If I break it into half, so volume will be halved now, right?
Yes.
But the density of both will be same now.
Oh, okay. Yeah,
Density,
got it.
how dense it is. So it may be small in size or larger in size. The density will remain the same.
Because the mass also will reduce.
Mass also will reduce proportionately.
Okay.
And you have to understand now that until and unless you change the temperature of a substance, no matter how much you break it or twist it, the density will not be changed.
Okay.
All right.
Yeah.
Now I guess we can find out.
Find the ratio.
So if the density is the same, density equals to mass upon volume. You solve it quickly right now. You have just 20 seconds. Quickly tell me the answer. The time has started now. 5 seconds gone. 10 seconds. Half time over.
Mass will also be 4:5 ratio.
Okay. Sure?
Sure. A little confused, but yeah.
No, why are you confused? See, density is
Because
what?
mass is equal to density into volume. So 4:5 into 1:1. That will be 4:5 only.
Density is mass upon volume, right?
Yeah.
And density for both are same, right?
Yes.
So you can say M1 V1 should be equal to M2 V2,
Yeah.
correct?
Yes.
Now whose ratio is given? Volume means V1 by V2 is given.
Yes.
So I can write M1 by M2 is V1 by V2, right?
Yes.
This is given 4 by 5, so this will also be 4 by 5.
4/5. Okay.
And naturally, see, density is mass upon volume. So if density is constant, then mass is proportional to volume. That is logical. If you keep the density of a substance constant, then if you go on increasing the volume, naturally mass will also increase, right?
Yeah.
Like say, for example, you have sugar. So
Sugar.
because it is sugar only, if you go on increasing the volume of sugar, what does that mean? You're adding mass.
Yes.
So mass will be proportional to volume if the density is constant. Got it?
Yeah.
Okay.
Got it.
So next question.
Next one is, I think it's the fourth one. 1 second. No, third one. Third one.
Two spheres made of same material have their radii in the ratio. Find the ratio of their. Now I tell you, you can calculate this one. Take your time and do it. Okay.
Okay.
Once try this now. You should be able to solve it. Okay. Next question.
Next is sixth one.
Sixth one. A cylinder is placed between two blocks of wood and a ruler is placed against the blocks. A cylinder is placed between two. Like you have to understand the figure first. See, I'll tell you, Amulya, when you're solving a question, like I don't know, you have sent me the solutions, but how much time you took have you written?
No, I have taken 1.5 hour in total, I think.
1.5 hour for what?
For entire.
Okay. 1.5 hour is fine. So now you see a cylinder is placed between two blocks of wood. So whenever I solve any question which appears to be lengthy,
Okay.
so how I solve, I'm showing you. Okay. Now
Okay.
please take a note of it. How I'm going to do. A cylinder is placed between two blocks of wood. And a ruler is placed against the blocks. The readings corresponding to the inner edge of the blocks, the reading corresponding to the inner edge of the blocks are 13 centimeter and 17.4 centimeter. What is the diameter of the cylinder? I
It's
think
very easy. It's 17.4 minus 4.4. Yes.
I want to check the answer first. I don't.
Okay.
Anyhow, if that is not the answer, then nothing else can be done
Okay.
to find the diameter. That has to be the answer.
Yeah, it's 4.4. It's correct.
Because anyhow, nothing else could be done.
Yeah.
I mean, if two readings are given and you're supposed to find the diameter, anyhow, logically nothing else can be done. But anyway, see, so how I solved the question, it took me how many seconds? 20, probably less than that. How we did, and that's how you are supposed to do. See, read the question and draw the figure in one shot. Cylinder is placed between two blocks of wood. I'm showing you. Cylinder placed
Yeah.
between two blocks of wood. Now, actually, you could have drawn like this also.
In the horizontal way.
You should have done, no problem. Now see what is being asked. And a ruler is placed against the blocks. Now the confusion is, should I place the ruler up to here only? That is a little confusion. So it said ruler is placed against the blocks.
Blocks. So
Blocks.
it's given
So it
in
should be like
blue.
this.
Yes.
With a ruler. And the now the reading corresponding to the inner edge of blocks. So inner edge should be this one because it is touching to the cylinder.
That's
Right?
the out. Yeah.
Like this can't be the inner edge, certainly. It's outer edge actually.
Yeah.
Now quickly I'll have the readings here. 13 centimeter and 17.4 centimeter.
So
And I can
just
get this will be the diameter. And in case anyhow you are not able to understand, say for example, still say for example, I'm not able to get it. Now logically also, if you see only two readings are given and I'm supposed to find the diameter, I can't do anything else also.
yes.
Anyhow, I have to subtract. So you can check the option once. If 4.4 is mentioned, you can just once close your eyes and mark it. But I'm not recommending that process anyway. Okay, got it?
Yeah.
Yeah,
Got it.
next question.
That's it.
That's it. Good.
Yeah.
All right. So you have solved everything. And once now whatever is remaining portion, you solve it out. And in order to bring this, I mean, some more questions I will ask you from my end so that you all are little more conceptually strong. All right.
Okay.
Okay. So you can now start solving. You have a pen and copy.
Yeah, I have.
So, and I will tell you the time limit. And if in that time limit you are not solving, then we'll move on to the next question.
Okay.
Okay. So for
I'm
the
not so used to doing in less time. Actually.
so you have to do it.
Yes.
So for the first question, before and only I'm telling, you have exactly 30 seconds.
Okay.
Right?
Okay.
I have here timer in front of me. First
Okay.
question, you have to hear and start solving. Question is very small. Find the time period of a pendulum of length 9.8 meter. Time started. You don't have to write the question. I'll give you. Find the time period of a pendulum of length 9.8 meters. Time period of a pendulum of length 9.8 meters.
Okay. 2 pi.
Very good, 25 seconds. Next question. What is the density of a liquid of relative density 1.7? Time started.
Can you repeat the question?
Relative density of a liquid is 1.7. What will be its density in kg per meter cube? Relative density 1.7. What will be its actual density kg per meter cube?
It's 1,700.
Okay, if you're 4 seconds late. Question number 3. Can we change the density of a substance?
We can change it only if it's melted or burnt or anything as such.
Basically by changing the temperature of that thing.
Temperature. Okay.
Either you change the temperature or even if you change the pressure applied on it, you can still change the density. So by adjusting the pressure and the temperature, it can be changed because, say for example, you take this much cotton and you put pressure on it and you make it this much.
Yeah.
So the mass of the cotton still remains the same, but the volume has become less.
So the density has increased.
Yes. So upon changing the pressure and the temperature, density will vary. But apart from that, no matter how much you break it or twist it, density is going to be the same for the material. All right.
Okay.
How many fundamental quantities are there?
Fundamental 7.
How many supplementary?
Supplementary, we have studied 18.
Supplementary quantities.
Supplementary, okay, it's 2.
What are those?
Plane angle and solid angle.
Plane angle formula.
Was it Theta?
That is theta. I mean, formula for theta was?
Formula for theta? I don't remember so clearly, but let me
Arc length
calculate.
upon radius. Okay. It's arc length upon radius.
By radius. Okay, fine.
See, you know angles, right?
Yeah.
So you know 180 degree.
Yes.
Have you heard that 180 degree is called pi radians?
No.
Okay, then I'm telling you, 180 degree is also called pi radians. Write down.
Oh, is it the formula of the semicircle?
It's not the formula, it's just a conversion. Like I had told you that the angle theta is represented in 2 units. Remember, 1 degree, 1 radian.
1 degree in radians, yes.
So what is the conversion? There should be some conversion, right?
Yeah.
And that is the conversion. You write down. First, 180 degrees pi radian. Done.
Yes.
Just pi. Don't write radian. Pi, and on top of that, power small c. That is called radian. I'm showing. Share my screen. Share my screen. Yeah, you're able to see my screen, right?
Yeah.
See, that's how we write. 180 degrees is pi radians. That's it.
Okay.
So this is a circle. I'm going to prove to you something right now.
Okay.
This angle is how much?
180.
And that is pi radians.
Okay.
What is the complete angle? Fast, tell.
Complete angle will be pi radian square.
In degree, you tell me. What is the total angle? This complete
Degree
angle?
360.
360. That's it. So how much pi? So on the left hand side, I'm doing 180 multiplied by 2 to get 360. On the right
Okay.
hand side, what I should do?
Pi into 2.
Yeah. So that is 2 pi.
2 pi. Yes.
Now you tell me, what is theta?
Theta is arc length by radius.
Yeah. Now never forget it.
Okay.
Arc length upon radius. Now you see, if you remember the diagram, it was somewhat like this, right? This was theta.
Yeah.
This was arc length. This
The
was radius,
cone.
right?
Yes.
Now this
Yes.
theta, if I make it 2 pi, how will this particular thing look like? Imagine if I make theta 2 pi, then what will it become? Fast. This theta is something right now, say 60 degree at this point of time. Say for example,
Okay.
if I make theta 360 degree, then how will it look like?
It would be a semicircle.
Complete circle, beta. This
Huh?
whole angle is 360 degree, na?
Yeah, if we increase it to 180 degrees.
Not 180. I told 360 degree.
2 pi. Okay. 2 pi. Okay, fine. Got it. It
Yeah.
would be a complete circle. Yes.
Complete circle, right?
Hmm.
So, okay. So now what is, so if I write theta, that is 360 degree or 2 pi, right?
Hmm.
This should be equal to arc length. In this case, it is a
Yes.
full circle.
Yes.
Pi what? Radius.
Radius.
What you got arc length?
Arc length is
Focus here. 2 pi is arc upon r. What is this arc now?
arc is circumference.
Yes. That is 2 pi r. From the formula you see, you send r here. You're getting?
Yes, 2 pi. Yes.
This is what I wanted to show you.
Okay.
You got it? Take 10 seconds
Yeah.
and just tell me whether you understood everything or not.
Yeah, understood. It's clear.
Sure?
Sure, clear.
So, okay. Now you have 1 minute to do it.
Hmm?
You find the length of arc of a circle which subtends an angle 120 degrees. Find the length of arc of a circle of radius r which subtends an angle of 120 degree at the center. Question is clear?
No.
Find the length of arc
120 degrees.
which subtends an angle 120 degree at the center.
Okay, got it.
Got it?
Yes.
Very good. Time started.
It's 2 pi r by 3.
Yeah, it's 2 pi r by 3. Good.
Yes.
Okay, 110 degree. Time started again. You have 1.5 minutes. Sorry, 1 minute. 110 degree.
Mm.
30 seconds.
2 pi r into 11 by 36.
Yes. So 2 pi r into 11 by.
36.
Okay. So it's 110 degrees, right?
Yeah.
So you can also use this method. Like when I say it's 180 degree, it is pi radians, right?
Yeah.
So 110 degree will be how much? Tell me.
Pi into 11 by 18.
Pi into 11 by 18. All right.
Yeah.
So I have got the angle now in radians. Whenever you use this formula to find the arc length, this formula, then you always have to put theta in radians, not in degree.
Not
All right.
Okay.
Write it there. For finding the arc length, theta should be in radians in terms of pi. Fast, fast, fast. Written?
Yeah, done.
Okay. So this is what is now what? So, I mean, pi into 11 by 18 is what? Theta.
Theta.
So that is arc by r, simple. So r you send it here, so that 11 pi r by 18. That's what you were telling or what? Yeah, I think that is what you were telling. 11 by 36 multiplied by 2 pi r.
Yeah. Yes. I've told 2 pi r into 11 by 36.
Yeah, that is also correct. You got it now?
Yeah, clear.
So any angle is asked, 37 degree, 53 degree. For 37 degree, what you have to do?
For
37
37 degree, I have to write pi.
pi by 180.
Yeah,
Is the
pi into
conversion into?
37 by 180. Yes.
This is conversion in radians and just multiply this by r.
Okay.
Sure?
Okay, clear.
Understood?
Yeah.
In future, you'll remember this forever?
Yes.
All right. So that you remember, I'm writing 5 questions. You find the arc length. I mean, not now. It's a homework. It's 15 degrees. It's 95 degrees. 150 degree. 170 degree. That much. Find the arc length. All right.
4 only.
Only 4. Yeah. Okay. Write down one more. 270 degree. All right.
Okay.
Done.
Yeah.
Okay. Now next question. We have found this thing. Okay. How many derived quantities we had learned?
We have learned 18.
I mean, how many derived quantities are there?
25?
It's undefined. We don't know how many derived quantities can be there.
Okay.
There are many derived quantities. Okay. 25 we studied, but there are many.
Many. Yeah, okay.
And we can't put a full stop to it also because tomorrow some new phenomena come, some new derived quantity may come up.
Yeah.
There is no fixed. Okay. Now you tell me. Okay, timer. Mass 10 kg. Write down. Written.
Mass 10
10
kg.
kg.
Yeah.
Tell me the weight in CGS unit. 30 seconds. Tell me the weight in CGS.
Acceleration. 10 into 10 to the power 5.
10 to the power 5. Okay. How did you solve it?
First the weight formula is mass into acceleration or gravity. I took it as 10 instead of 9.8. So 10 into 10 100. Then I converted into grams. That is into 10 to the power 3. So 10 to the power 2 into 10 to the power 3 is 10 to the power 5.
And below centimeter is also there, na?
What centimeter?
Like 10 k, like you are getting 100 newtons, right?
Yeah.
So 100 Newton means kg meter per second square. So it is what you said, 100 into 10 to the power 5.
No, only 10 to the power 5.
Okay, so you missed that meter. Meter also you have to change.
Yes, okay. It should be 100 into 10 to the power 5 or 10 to the power 7.
Yeah, got it?
Got it.
So essentially, if you would have, say, it's 98 newtons precisely, okay?
Okay.
And CGS unit is also called dyne, I had told.
Dyne, yes.
And 1 Newton is 980 dynes.
989.
So directly
Yes.
98 multiplied by 980.
Yeah.
That way also. Okay.
Hmm.
Okay, next question. What do you think the density will be more for? Option A is dry air, the air which you are having in your surroundings. It's called dry air. It has,
Okay.
what all things it has? Oxygen, nitrogen mainly, hydrogen, and so on. And on the other side, I have air which is humid air. Humid air means there are some water droplets also in it.
Okay.
So which one do you think will have more density? Which one will be more dense? Given a specific volume. Volume is fixed for both. You take container, two equal volume containers, and in one you put dry air, in another you put humid air. Whose density will be more? Okay, yeah, 30 seconds to think. Give an explanation.
Dry air.
Why?
Dry air because in the humid air, the volume will be, the mass will be more because the water droplets mass also will be included.
Okay.
So the density will be lesser. While in
1 minute. If the mass of the water is included in humid air, and you are saying the mass is more in case of humid air, right?
yeah.
Now I have already specified that the volume of both is same. So if the mass of the humid air is more, the volume is same for both, then the density of humid air should be more.
Okay.
What logic you were using, you tell me?
What was your question? Wasn't clear.
Like what logic you were using, you tell me?
I thought if volume is more, the density will be less.
Yeah, but I had initially specified, you remember, that you have to take equal volume containers.
Yeah, got it.
Got it?
Yeah.
Now, actually speaking, this is wrong answer. The answer is that the density of dry air is more actually. The density of dry air is more than that of humid air. Why? I'll show you. Share my screen. Wait. Okay, you're able to see my screen?
No.
Oh.
Yeah.
Still
Still
no?
presenting still.
Okay. Still not coming? I think signal is weak or what?
No, it's full internet.
I mean, my internet is also okay. It's still not coming?
Mm-hmm.
Okay, wait. Start. Now came?
Yeah, yes. Okay.
Okay. See, there are two containers. They're equal volume. Okay. So this is V1 and this is V2. Both have equal volumes. All right.
Okay.
Now, say this one is dry air and this is still like this is humid air. Dry, humid. So in dry air, the particles which are present is of oxygen, nitrogen, hydrogen, and so on.
Okay.
And in humid air also these things are there, but
With
water is also
water.
there. Okay.
Hmm.
Now, it's not that, and whatever the mass is here of these different molecules, exactly same mass they have here also. Like say if here is 10 gram of this air present.
Hmm.
So in humid air, it's not that these 10 gram is present plus water is
Because
present.
water is, it's not big,
Not like
because
that.
in the same volume so much cannot be there.
So therefore, some of these molecules have to be replaced with water molecules. That is called humid air.
Okay.
So humid air does not mean that पहले जो था उतना है and you add water to it. I mean water, small droplets.
Okay.
You have to replace some. Okay.
Hmm.
Now, weight of one molecule of water, not one molecule, like this one molecule which is there, H2O.
Hmm.
I'm just mentioning one word. Its molar mass is 18 grams.
What is molar?
Molar, I'll teach you that in chemistry. Okay, you can understand. See, molar mass basically means the weight of or the mass of 6.023 into 10 to the power 23 molecules of anything is called molar mass of that thing.
Is atomic mass and molar mass same?
It's different actually. Atomic mass, you know?
Yeah.
Okay, what is atomic mass of oxygen?
Atomic mass, it is 8, is it?
Atomic mass is 8, yes.
Yeah, because atomic number and atomic mass are the same.
So you can consider the like that also. Like atomic mass of H2O, it will be 8 plus 2, 10. Like 2 for
Yes.
hydrogen, okay?
Yes.
And for oxygen, what it will be? 16. It's 2 oxygen atoms.
Yeah. Okay.
So therefore, atomic mass of oxygen is what? More. Similarly, you got this or not?
Why
Like
16? I didn't understand.
because 2 oxygen molecules are there, no? So one oxygen 8, another oxygen 8.
What if one molecule is there, what is it called? Is it also called oxygen only?
No, actually this does not exist. Simple O does not exist.
Okay.
It occurs in bond. O and O together they exist. Like 2, like 3 also won't exist. Sorry, O3 exists. It's called ozone.
Ozone is O3. Okay.
Yeah. And O2 is oxygen. Independent oxygen atom doesn't exist. I mean, it doesn't exist in nature. Like we
But
can.
the atomic mass of independent oxygen is 8. Okay.
Okay.
Yeah.
So in air we have O2.
Yeah.
So therefore its atomic mass of this it's called molecular mass now because O2 is called molecule. O is called atom.
Okay.
So O2 is what? It's a
O
molecule.
molecule.
And the mass of its molecular weight is 16. So you remove molar weight from here for the time being. Let's understand this. So O2 is 16. You got it?
Yes.
And N2 will be how much? Nitrogen 1 atomic mass is 7.
I don't know about nitrogen.
Okay, I'm telling 7. Okay.
Okay.
So for N2 will be 14.
Good. Okay.
Whereas for oxygen it is
16.
Yeah. For oxygen is 16. So therefore, H2O actually has less molecular mass than O2 and N2.
Okay.
You got it?
Yeah, understanding a little.
Little bit.
Yeah, because that is 8 and this is 16 plus 14, that is lesser.
Yeah.
Okay, got it.
Got it?
Yeah.
So it's like that. So therefore, when you replace O2 and N2 with H2O, then actually the mass reduces.
Okay.
Got it?
Yeah.
So mass reduces and volume remains same. So therefore the
So
density
dry air, it is
more dense.
okay.
You understood little bit?
Yeah.
Okay. So the next class maybe I'll explain these things, molecular mass and all that.
Okay.
Okay. This much you understood that which is more dense, dry air or humid air?
Yeah, I understood.
Which is more dense?
Dry air.
Yeah. So although it looks humid is more dense because water molecules are there, but actually dry air will be more dense. Okay. This is a standard question that is asked. Okay. Now you tell if there is water, say at 50 degrees centigrade,
Okay.
and if I heat it, its density will increase or decrease? Water is at 50 degrees centigrade. I'm heating the water. Density will increase or decrease?
Decrease.
Why?
Because the temperature is changing.
So why decrease? Why not increase? So generally, whenever you heat anything, no,
Yeah.
so it has a tendency to expand.
Okay.
So the mass is same.
Has the same
The
volume.
volume has increased.
Yeah.
So the density
Density will decrease.
got it.
Yeah.
Now, if I decrease, I mean the temperature from 50 degrees Celsius, decrease it like 30, 20 like that. So now will the density increase or decrease of water?
Can you repeat the question? I'm not understanding.
From 50 degrees centigrade, when I had increased the temperature, density decreased, right?
Yeah.
Now I am saying from 50 degrees centigrade, we are reducing the temperature, so the density will what?
Density will increase.
Yeah. So if you cool it, the density should increase, right?
Yes.
You're able to see my screen?
Yeah, it's visible. Visible.
Okay, okay. See, now what happens, I'm telling you something. This density increases certainly. If you cool something means they will want the molecules that come closer to each other. Like say 10 people are in a room.
Yeah.
Or you have you seen monkeys sleeping in winter season?
No.
I have not seen. Like
No.
they at least 20, 30 of them sleep, keeping them on each other to get the warmth.
Okay.
So in winter season they come close to each other. Summer season they are apart. Similarly, the molecules also, if you cool them, they tend to come closer to each other.
Okay.
Actually, the vibrational energy which they have, if you cool it, then the vibrational energy becomes less, and therefore they shrink or contract.
Yeah.
And if you heat it, their vibration energy increases, so their volume also increases. Got it?
Yeah, got it.
Now, in the case of water, something special happens. See, this temperature is 4 degrees centigrade. You're able to see?
Yeah, 4 degrees.
Yeah. Now, what happens? I'm drawing density graph, density and temperature graph. Graph, you understand?
Yes.
What happens that when you decrease the temperature, the density should what?
Well, the density should increase.
Density should increase, right?
Yeah.
So it happens like this. The density is increasing
Yeah.
when I'm reducing the temperature. It's clear?
Yes.
I'm just drawing this a little more apart. You're drawing this graph, right?
Yes. Yes.
Yes. So now, till 4 degrees centigrade, what happened? The density is increasing, right?
Yes.
And now, abnormally, what happens? If you still cool it further below 4 degree, the density, rather than increasing, decreases.
Right?
It's God's creation. Because it further decreases actually. Okay.
Like if it is -4, it decreases.
If it is beyond, if it is, if you like, say for example, the initial temperature we started cooling was from 70 degrees centigrade. All right.
Okay.
You keep on cooling, keep on cooling. What will happen to the density? It should increase because I'm cooling. The density is increasing, right?
Yeah.
But if you cross 4-degree mark and still keep on cooling, then abnormally density decreases.
Only for water, right?
Only for water.
Okay.
So
Okay.
this phenomena is called anomalous expansion of water. Right now, it's called anomalous expansion of water. Why it's called anomalous expansion? Because when from 0 degree centigrade to 4 degree centigrade we heat it,
Yeah.
rather than decreasing density, it increases only.
Okay.
You see, generally when you heat, what happens? Density should decrease, right?
Decrease.
It should become more thin, the liquid.
Yes.
But for water, when you heat it from 0 to 4 degree centigrade, its density abnormally increases actually.
Okay.
And this is a very speciality of God's creation. You know why?
Why?
Because what happens, you know, ice floats on water. Have you ever seen?
No.
You have never seen?
No.
You might have seen Discovery Channel, big icebergs floating in water. You have never seen ice floating in water?
No.
You have your fridge.
Yeah.
You can go and take one ice after the class, put it in the water. You'll see it will float.
Yes. Have seen in all the other liquids, but not water.
You check with water.
Yes.
I'm going to tell you something special. Hear it attentively. Huh? What
Okay.
happens when we heat it at 0 degree centigrade? What happens? Water starts converting into ice.
Yes. Yes.
I mean, H2O तो दोनों ही है. I mean to say, water gets converted to
Ice.
ice.
Yeah.
And the density will increase or decrease?
The density will
Decrease. I'm
decrease.
cooling.
Okay.
It should increase, but the density decreases, right?
Decreases. Yeah.
So although it seems that ice density should be more, but amazingly water's density is more, although ice is solid and water is liquid.
Both are just almost same. At 0 degree, from 0 degree also it keeps decreasing.
I mean, at 0 degrees Celsius, what happens is that, actually, see, I'll go into little details, okay?
Okay.
See, I'll draw it here. I hope you're able to understand the things, right?
Yes, yes.
70 degrees centigrade was water.
Okay.
You cooled it. 50 degrees centigrade is water. And the density is what?
Density will
Increase.
increase. Okay.
70 to 50, right? So it should increase. I'm cooling.
Increase, it's less.
Okay. Now 10 degrees centigrade. Still water.
Water.
Density has further increased. Okay. I am reaching 4 degrees centigrade. It's still water. The density is
increases.
now the density is maximum.
Max. So
It is
10 to the power 3 is the maximum.
10 to the power 3 is maximum because we take that at 4 degrees centigrade only.
Okay.
Now you understood that why in relative density formula was given for 4 degrees centigrade.
Yes, yes, understood.
Yeah. Now you know after 4 degrees centigrade what happens? If you further heat it, and now you say the temperature is say 3
0.
degrees centigrade. Say
Oh.
3 degrees. Let us take one intermediate. It's still water.
Density decrease.
And the density decreases from here. Like from here, the density relatively has decreased now.
Okay.
Okay, and it's still water, mind you. Okay. Further cool it. Now say I have cooled it to 0 degree centigrade. All right.
Yeah.
Now watch carefully. At 0 degree centigrade, say for example, I had here 0. Say 1 kg water. All right.
Okay.
I had 1 kg water initially. At 0 degree centigrade, when it just reaches 0 degree centigrade, the temperature, it will still be 1 kg water. Just it has reached there. All right.
Okay.
1 kg water and the density is what? It is still decreasing.
Yes.
Decreased from where? From here, from 3 degree centigrade to whatever was its density, it has now further decreased at 0 degree. Okay.
Okay.
Now, first now understand, then copy. At 0 degree centigrade, this 1 kg water now at 0 degree centigrade only. Now it will further start condensing to ice.
Ice.
This is called what? Freezing point or melting point both. It is a freezing point also.
Even melting.
And also the melting point. Okay. So now gradually, if you further cool it, then 1 kg water will what? See, if you just have arrived at 0 degree centigrade, wait, first try to understand. If you arrived at 0 degree centigrade just now, it will remain always water only. Nothing will happen. It won't convert into ice.
Okay.
Got this much?
Yeah.
But if you further cool it from here
to -1, it changes to ice.
No, beta. When you now cool it, the temperature will remain constant. So long, the entire water is converted to ice. I'll explain once again, but just once try to understand. So long, water is there, keeps getting converted to ice. Got it? So now you see, I kept on reducing temperature from 70 degree to 50 to like this. I came till 3 degree, then I came till 0 degree. I came at 0 degree, means it's still water at 0 degree centigrade.
Okay.
Now, if you further reduce the temperature, I mean, how can you reduce the temperature? There is no like hard, like it's not the 10 degree tha. I clung on to 10 degree and I pulled it down, it became 4 degree. It's not like that. Reducing temperature means you are somehow or the other putting it in a refrigerator or, extracting heat by some way or the other. Got it?
Okay.
So at 0 degree centigrade water also, if you try to extract some heat, you will extract the heat certainly, but the temperature won't change. See, heat and temperature are two different things. Heat is energy and temperature is the hotness or coolness of a body. You got it?
Yeah.
Heat is what?
Heat is energy.
And what is temperature?
Heatness or coolness of a body.
Yes. So if you further extract heat from here, 0 degree, what is going to happen? Something is surely going to happen.
Heat is reducing.
Yeah. And heat will be certainly reduced, but the temperature will not change. Then where that heat, which like say I'm ice. Okay. And what is my temperature right now?
0 degree.
I'm releasing more heat.
Yeah.
My temperature is changing or not?
It won't.
Not changing, right?
Yeah.
Then what is the use of my releasing heat? Something should happen, right?
Yes.
So now what happens? The molecules of the water which is there, when the heat is further released, they come closer and they form ice. So this heat which is released, yes.
But why doesn't temperature reduce?
That is what is the observation. There is no argument for it. Why it happens? It is just like that only. We have observed that when you further cool 0 degree water, it starts getting frozen to ice and the temperature remains 0 degree. And from there we concluded that when the state change happens, either from solid to liquid, liquid to solid, gas to wave, whatever state change you take, solid, liquid, gas, whenever some state change happens, temperature remains constant. And the energy supplied or gained is used by the molecules to either come closer or go farther to change from one state to another.
Okay.
You got it or not?
Got it. Got it.
Yeah. So I'm still releasing heat, right?
Yes.
But now by releasing that heat, the molecules are coming so close that now the water is now getting transformed into ice. So yes, I'm releasing heat, but it won't reduce the temperature from 0 degree now. First, what is going to happen? First, complete all the water should be transformed into ice, and then only the temperature can further change. It's a breaker there. You got it?
Even after all the water changes to ice, also it can't go to -1 and all.
Now I'm telling. Now you understood that at least 0 degree may first all the water gets converted to ice. Okay.
Yes.
Now what I have full-fledged ice of 1 kg. Full water got converted to 1 kg ice, right?
1 kg ice.
Now if you cool it, certainly it will go below 0 degree.
Oh.
So now -5 degree. You can further cool it to -20, 30, whatever you want.
Okay. Got it.
Now it will go on further getting cool. Clear?
Yeah. Clear.
And the reverse process is also applicable. Say -30 degrees Celsius, water will exist or ice?
Ice.
Only ice will exist.
Yes.
Okay. If you further heat it, say 5 degrees centigrade, water or ice?
Ice.
Further heat it, now just 0 degree, water, ice or both? Just 0 degree पहुंचा है अभी. Only ice.
Ice. Okay.
Further, if you heat it, now what happens? Temperature increases.
Temperature, no, it remains 0 degree until all the ice changes to water.
Very good. So now this is straight transition. So temperature will remain 0 degree. Now say for example, you gave it little heat and left. So that all the ice is also not converted fully into water. So now in that situation, both the ice and water will coexist together at 0 degree centigrade only.
Okay.
You got it? If you left it, huh?
Water and ice both. Okay.
Both will coexist. I mean, nothing is going to happen. Like ice will keep hanging like this only. Generally, it doesn't happen like that. If you take ice and put it in water, it melts, right? But at 0 degree Celsius, if you maintain the surrounding, the ice and the water, they will coexist.
Okay.
See what will actually happen. I'm showing you little details so that you fully understand it. Say, this is my 1 kg ice. All right.
Okay. Yeah.
What is the temperature just now? 0 degree.
Just okay.
Okay, means you just kept on heating. Now the temperature of 1 degree, like this 1 kg ice becomes 0 degree, right?
Yes.
It will still remain ice, mind you. Now if you heat it little more also, even little more you heat, some like what with that heat now, it will remain at 0 degree only, but some portion of the ice will melt. Got it?
Okay.
Say for example, now ice becomes this much, little smaller in size. Say 800 gram remained. So how much gram got transformed to water?
200.
So you have 200 gram water hanging like this and 800 gram of ice. What is the temperature?
0 degree.
Yeah, temperature will not change until all the ice gets transformed. Remember this. Even if you heat the water, you have to assume that you have to assume you won't separately heat the water. You have to give it like this heat. Okay.
Yes.
So it is as if the ice only steals all the heat. Water gets nothing.
Okay.
It is like that only. It's a phenomena. Only ice will take all the heat. Nothing will happen to the water. Water will remain like that. So now further you heat it. Now the ice further gets reduced. Now this much only ice remains. So
500 grams.
say 100 gram remains. So how much water now?
900 grams.
900 gram water, 100 gram ice.
Yes.
What is the temperature?
0 degree.
Still 0 degree. Now if you don't heat it, just leave it like this, then what is going to happen, you know? This is going to remain forever. If you maintain the temperature, of course. See, not heating means temperature will be maintained.
Okay.
I mean, if you heat it, temperature may change or may not change. But if temperature has changed 100 degree, you have given heat. I mean 100% you have given heat.
Okay. Yeah.
If you are giving heat, is it necessary that temperature will change?
Yes.
I repeat my question. Listen carefully.
Hmm.
If heat is given, temperature must change. True or false?
False.
Why?
Like if we take the example of this situation, only we are giving heat, and but the temperature remains 0 degree.
Yeah. So in any state change, either liquid to gas also,
Okay.
same thing is going to happen. Water 100 degrees centigrade, no?
Yeah.
If you keep on heating it, first all the water must get converted to vapor, water vapor.
Hmm.
Okay?
Yeah.
Then finally what you will get, all the water got converted to water vapor. So you have water vapor at now at 100 degrees centigrade.
Okay.
And keep on further heating it now, the water vapor temperature will become 110 degrees centigrade, 120 degrees centigrade, and so on. You will never find water at 110 degrees centigrade. That is not possible.
Yeah, it will become water then.
Yeah. Water only exists between 0 degree to 100 degree.
Yeah.
Okay. If I change the temperature, if temperature is changed, heat must be given. True or false? Heat must have been given. True or false?
False.
Why?
It's false because if temperature changed, it can even increase. That time heat must be reduced.
Repeat.
Like temperature is changing. It is not like heat is temperature is increasing or decreasing. So if temperature is decreasing, heat should be reduced.
Yes. Okay. So basically, then I'm changing the statement. Say heat must be either given or taken away. Then
That time it's true.
okay. So now it's true, right?
Yeah.
Actually, when you go to class 11, then this will also be false. But for the timing, and assume it's true.
But why false?
Actually, total heat which is given to a system, na, some portion of the heat goes in work done. I mean, leave it for the time. Like some portion of the it goes in work done, and some portion changes the temperature.
Okay. Okay.
Like I like say for example, I jump 100 times up and down. Has somebody given me heat?
No.
Will my temperature increase?
No.
Sure. You try jumping up and down 100 times, your body temperature will certainly increase.
Increase.
Don't you think so?
I have tried this because I daily do skipping, but I never felt my temperature increase.
See, if your temperature will not increase, then why will you sweat?
Okay.
Sweating happens to cool the body.
Yeah, got it.
So sometimes even without giving heat, we can increase the temperature of a system by doing some work on the system. Okay?
Okay, yeah.
For the timing, you can just skip it. For just your understanding, I told. But for the timing, this much is essential. What I told before. That if temperature is changed, heat must be given. Till
Yeah.
class 10th syllabus, it's okay. Okay?
Yeah.
And don't worry, if you still want to know more, you tell me, I'm ready. I'm ready to go up to any extent. It depends on you. You should be able to digest the things. So far, so good. Till we'll remain here, and then you tell me more details you want.
Okay.
But this much is clear, right?
This much is clear.
So this much you see, the ice and water will coexist at 0 degrees centigrade. That is speciality.
Okay.
And now, finally, you know what will happen. Finally, at 0 degrees centigrade, all the water, I mean, all the ice will get converted to what?
All the ice will get converted to water.
Now, water can be further heated, no problem. But then ice won't remain. You can't say ice at temperature of 10 degrees centigrade. That is not possible. Got it?
Okay. Yeah.
Now you are asking that, sir, why the density of the ice reduces, right?
Yes.
I'll answer now why. Why ice density lesser than the density of water? Now for this you need to understand little bit about the nature. You have seen sometimes in Antarctica or the North Poles, the living creatures who are there, the aquatics, actually the temperature in the poles, they go below 0 degree centigrade.
Yeah.
Correct, no?
Yeah.
At poles, the temperature is less than 0 degree centigrade, right?
Yes. Yeah.
If now imagine there is a lake or there is a river or there are oceans also sometimes, right?
Yeah.
Now the temperature of the entire ocean is below 0 degree centigrade.
Yes.
What miracle is going to happen? The entire ocean will freeze.
Freeze. Yeah.
And what will happen to the whales and dolphins? What do you think?
They have to migrate.
If an entire ocean is getting frozen, I don't think they can migrate. In fact,
Yeah.
there are many, like, you can't migrate an ocean. Or say, for example, the whales
Yes.
can migrate also. They can travel quite a large distances, but still they also don't travel very large distances. They have their own area.
Yeah.
And what about then small fishes, jellyfish, this fish, that fish, tortoises? Many things may be there, right?
They'll all freeze.
But they will be frozen to death, right?
Of course, yes.
What God did, God said that they all will be frozen to death. They are also my children. Therefore, what God did, He said that when water will go below 4, when I cool the water below 4 degree, there is a graph here. When I cool the water below 4 degree,
Yeah.
let me decrease the density of ice. By doing that,
Okay.
ice will float on water.
Hmm.
If the density of something is less than water, it floats on water.
Floats on water. Yeah.
You know this?
Yes, yes.
Okay. Now what happens? The freezing happens from the topmost layer. It
Yes.
got frozen. Okay.
Yeah.
Now, if this portion gets frozen and if the density of the water would have further increased upon cooling below 4 degree also, then density of ice would have been more.
More.
Then it would have,
And the ice would come down.
then water would go up.
And again, the next layer will freeze. Again, that would happen.
Then whole ocean would get frozen.
Frozen. Yes.
So therefore, the mechanism is that density of ice is actually less.
Okay.
So it floats.
Okay.
Therefore, icebergs, they float. The Titanic got stuck due to an iceberg.
Yes. Iceberg.
They float, or the ice floats. And because the ice floats, this portion which is there, which gets frozen on the top, it insulates the bottom ocean from getting further frozen.
Okay.
You got it?
Yeah. Understanding.
This portion acts as an insulator. So the fishes who are there, they can peacefully roam inside.
Hmm.
Got it?
So they should be only deeper in the water. That's it.
Yeah, of course.
Okay.
Like
got it.
fishes, like you take fishes or the sharks, all of them can remain peaceful now.
Yes.
Got it?
Yes.
So therefore, the water of the, I mean, when you cool the water below 4 degree, the density should decrease or increase.
Can you repeat the question? I wasn't able to hear.
If the water is cooled below 4 degree centigrade,
Yes.
should the density increase or decrease?
The density should. I'm getting confused once.
If we cool it below 4 degree, the density should decrease so that ice floats on the top.
Yes.
Okay, don't worry, it will take a little time, but you go through whatever we have studied, you'll be able to understand.
Okay.
All right.
Yes.
So this is all about density. There are some more things that I had to ask. You have time? Shall I ask?
Yeah. Sure.
Okay. Okay. So anomalous expansion of water is clear. Okay.
Okay.
Now
Clear.
further, you have seen that if you place a needle in water, it sinks. You can try doing that.
Needle in water, yes, the density is more.
The density of the needle, say it's an aluminum needle. Okay. So it will sink. You can try. You
Yeah.
take a needle, you put it in the water, it will sink, right?
Yes, yes.
Say it's made up of aluminum. Okay.
Okay.
Now, say for example, I take a huge ship, which is tons and tons of weight.
Yes.
That is also made up of aluminum, but that floats in oceans. Why?
Because the bottom part, actually it is streamlined shape. That is, the bottom part is completely hollow and that would be inside the water.
Hmm.
And that increases the volume of the ship, and therefore, and it also displaces some water because it occupies some place in the ocean. So the some water is like sent out, and therefore it will float.
Like some water is set out. You can't set out water from an ocean.
Like I'm not understanding how to tell.
See, what you said is absolutely correct. The portion of the sink which is there inside the ocean, it is hollow.
Yes.
So the volume of the thing which is there, ship is like this. Ship is closed
Yes.
somewhat like this. Like okay.
Yes.
So the hand portion is aluminum, but this portion is also to be counted.
Yes.
And this is hollow, right?
Hollow, completely hollow.
So volume of the ship is much large in comparison to the mass of it.
Yes.
Overall density reduces. Volume increased. So density reduced. So like I'll draw a picture and just explain. You're able to see my this screen notebook?
Yeah. Yes.
So this is ocean. I'm sorry, this is ship. Okay. And this is ocean. All right.
Okay.
So now this submerged portion which is there now, overall density of this entire thing, the yellow thing, overall density.
Okay.
Overall density is the like total density is the total mass by total volume, right?
Yes.
It is the mass of the aluminium plus the mass of air by the total volume. Okay. This comes out to be less than the density of water actually.
Yes.
This thing dominates.
Yeah. Because it occupies more space.
Yeah. So this is very less and it gives a lot of volume. This total volume also can be divided into two parts, the volume of aluminium plus the volume of air. So this is very large, whereas this is very small. Got it?
Yeah.
So overall density becomes less than water. That's why it floats. Okay.
Yeah.
So if you take only the aluminium portion of the ship like this, say the aluminium portion I'm drawing in this pink. If this aluminium portion you take, melt it and make it into a big sphere. Make it a big sphere, okay? And now you put it in the ocean. It will certainly sink.
Oh, yeah, of course. Yeah.
Got it?
Yeah.
Okay, na?
Yeah, got it.
So then it will sink because there is no empty space, na? So therefore it will sink. But this will float.
Okay.
Sure?
Yeah, clear.
Okay. Just a few more questions.
Sir, I have one doubt.
Uh,
Now there is an experiment, like we have to add many different types of things in water, like oil, honey, all this, and they will settle in layers, and some
they
will
will.
settle in layers.
Okay.
Some will be in the middle portion. Like, how is that sinking or floating or what it is called?
Actually, something is in the middle also, it is floating on.
Floating? Okay.
I'll teach you that in the next class in details
Okay.
about the flotation, because that's a separate thing then altogether.
Sure.
Actually, flotation means, like, say, for example, if a ball is floating, na, uh, usually it will remain either on the top or on the bottom. Usually you won't find a layer, something like, say, for example, you mix oil in water,
It will be on the top.
either it will be on the top or some oil may go down if its density is more than water. Okay.
But how will some oil float and some oil go down?
Because there are different varieties of oil, na. So
Okay.
if I mean to say, if there is some oil whose density is more than that of water,
Okay.
in that case it has to go down.
Okay.
Clear?
Yeah. Yes.
Now I don't know which oil has density more than water, but I'm speaking on the basis of principles.
Okay.
Principle is clear?
Yeah. Clear.
Now my question is, say for example, I have poured oil and the
Okay.
jar is transparent. So I can clearly observe that there is some oil, like this is, say, from here to here is water. If I pour oil, oil is visible here also in this area, central area.
Yes.
Why is that? It should either be up or down.
Might be the density is little more than floating.
Even if it's little more, then it will come down. What you have said is correct only. See, just because we have poured it instantaneously, na?
Yeah.
So it pushes some water and stays in the middle for some time.
Then again it comes.
But if you leave it for like 4 or 5 hours, then it will again either go up or go down.
Okay.
That is what is going to happen. Okay.
Okay.
Okay. So today we discussed the doubts, and we had some question answers to clear certain things, especially the time period, relative density. A lot of discussion we did on density mainly.
Yes.
Okay, so the next class will start with motion, and what I will do, I will also simultaneously give you some assignments for bio.
Okay.
So bio you cover side by side, and I'll tell you also how to do that.
Okay.
All
Yeah.
right.
Yes.
So that will then keep up, like we can keep up with the pace. Otherwise, like physics part will be taken care of like 1.5 hour weekly on basis, but bio and chemistry will be behind. So for bio, I'll also simultaneously then now start giving you assignments and I'll guide you how to go with that.
Yeah. Because mainly this book is of physics and chemistry is at the ending part.
Yeah.
So mainly started with physics.
Okay, yeah, sure, why not? But then bio also will cover side by side, so that once we cover the things, now then we can go into more depth also
Sure.
of physics.
So evening, what about the math class?
Evening, when should I take you? Tell me.
Sir, I don't think today is possible.
Okay, then 4:30 to 6. Then tomorrow it's Wednesday. Tomorrow it won't be possible. Tomorrow I'll be busy. Then we day after tomorrow. Actually,
So because from Thursday, my the before teacher whom my mother mentioned will start taking classes.
So that's
That
why
to
she
9
was
to 10.
9 to 10 a.m.
Yeah, AM.
Okay, that's why she was telling. Your mother is there besides you?
Not here. She went downstairs to prepare food.
Okay.
Because there's some medical emergency. My grandfather had just heart pain and he was admitted to hospital yesterday.
Yesterday. Okay, so today you're going to visit him in evening.
No, they're not gonna let me visit. But there are not many people in her house, so we should be downstairs, and I should be helping. So I cannot attend, I think.
Okay. You can once and confirm from your mother, beta, because your mother was saying that maybe today or tomorrow I can take.
I'll ask her once.
Yeah. You asked. So she was saying that from 5th your math teacher is going to start, na?
Yeah, that is Thursday. Yes,
Thursday. So therefore she was telling that you can also once take.
Today morning she was saying ask him for tomorrow, so I just asked.
You ask her about it because tomorrow I'll be busy like from morning till maybe night also.
Okay. Tomorrow anytime will be fine because I have nothing on Wednesdays.
Wednesday, na? Then tomorrow morning 6 o'clock.
Yeah, 6 o'clock is also fine.
Morning.
Yeah,
Okay, then tomorrow morning then possible. Or morning 5:30 to 6:30, that is also possible for me.
anytime, anything you tell.
Okay, then if that is fine, then I'll let you.
Okay, you can WhatsApp.
Okay, I'll WhatsApp. Okay, thank you. Huh?
Thank you, sir. Bye.
Take care. Bye.